the process of tunneling. So it is through the tunneling. As you know, there is a header is added. So when the home agent send data to the foreign agent, because you are in foreign network, so the home agent is send data to. It is not only send the data itself. It adds some extra information, that is the address of corresponding nodes, and there is a dedicated path. There is a dedicated path between the home agent and the foreign agent, that is known as the tunnel, and the process is known as tunneling, and this address is known as the care of address. So these are the term used for architecture of mobile IP. So mobile IP plays a vital role. Without the option of the mobile IP, the data communication cannot be possible when you are traveling in a wireless medium. Because where you are traveling, you must have a wireless devices like your phone, like your laptop, whatever maybe you have wireless devices. Working of mobile IP. The working of mobile IP can be described in three phases: agent discovery, registration, and tunneling. It is also these three phases are important. Let us first discuss agent discovery. If the agent discovery phase, in this phase, the mobile nodes discover their foreign and the home agent. The home agent and foreign agent advise their services on the network using the ICMP router discovery protocol, IRDP. That means, as we discussed, that is when we are leaving your home network and entering to another network, your home agent and foreign agent have an agreement. That is the home, it sends the a message to the home agent that the mobile node which is originally belongs to you, which is originally belongs to you, now it comes under me. That is, it comes in my network. If any data comes to you, please send me. I will be responsible to deliver that packet data to that mobile node, because it is now present in my network. So the home agent know that where are you. So in between, if any data comes for you, if your corresponding node or your friend send data from you, that you, that is the home agent send the data to the foreign. How do you know? You know that is a tunneling process. We'll discuss about that. There should be a dedicated path that is called tunneling. Tunnel, and the process is known as the tunneling. It is send that data through that tunnel. But before that, so there should be agent discovery. That is the agent, both agent will know that where the mobile IP is. Then registration. In this phase, is responsible for informing the current location of the home agent and foreign agent for the current forward of the packet. So any packet comes from the for the mobile node, it is now forwarded to the foreign agent because there is a registration, that is home agent and this between the home agent and the foreign agent. Tunneling. The phase is used to establish a virtual connection. As you told, it is a virtual connection. It is a dedicated connection as a pipe for moving the data packets between a tunnel entry and a tunnel endpoint. As the name suggests, tunnel, so there should be no interface between this. The data will be delivered in the one endpoint and would be delivered to another endpoint. End-to-end communication. And this process is known as the tunneling. And there, so these are the working of mobile IP. That is the agent discovery, registration, and tunneling. One minute. Then the application. The mobile IP technology is used in many applications where the sudden changes in network connectivity and IP address can cause problem. That is, if the sudden change in network connectivity, suppose you are traveling in a moving vehicles, then you are suddenly changing your network. So mobile IP technology used in this type of application so that your communication will not be dropped. You continuous communication without changing your permanent IP. It is used in many wire and wireless environment where user have to carry their mobile devices across multiple LAN subnets. So you are traveling, if you are using a multiple LAN, so this is also useful. One minute. Then cellular network. So this is all about the mobile IP, its architectures, its working principles, and how does it work. The cellular network is formed of some cells. The next is cellular network. The cellular network cellular network is formed of some cells. Cells cover a geographical region. As a base station is analogous to 802.11 AP, which helps mobile user attached to network, and there is an air interface of physical link layer protocol between the mobile and the base station. As the base station are connected to mobile switching center, we have already discussed the mobile switching center, MST, BSS. So all their base stations are connected to mobile switching center, which connects cells to the wide area network, manages call setup and handles mobility. There are some hierarchy you see. It depends upon the number of cells. Is it is the smallest unit of so these cells needs to cover only a few meters where all the devices are in the physical range of the user. So it is the smallest unit of hierarchy. Then picocells. The size of this network is in the range of few tens of meter. That is 20, 50, 20, 50, 40, like 10 meters. That is also known as WLANs. Microcells. They cover a range of hundred of meters in urban area to support PCS, which is another kind of mobile technology. And macro cells cover the area of the order of several kilometers, cover metropolitan areas, 10 kilometers, 20 kilometers, some several kilometers, suppose a small metropolitan city. And mega cells cover the nationwide area with a range of the hundreds of kilometers using satellites. So depending upon the number of the distance, they are divided into these terms. Then come to the ad hoc network. An ad hoc network is one that is spontaneously formed when the device connect and communicate with each other. The term ad hoc is a Latin word that it means for this, implying improvise and important. And the ad hoc network are mostly wireless local area network LAN. The device communication with each other directly instead of relying on a base station or access point as in wireless LANs for data transfer coordination. And each device participate in a routing activity by determining the route using the routing algorithm. There are some routing algorithm and forwarding data to other device via this route. Suppose as we discussed, there is a various way from uh, Other networks can be classified into several types depending upon the nature of their applications. The most prominent and ad hoc network that are commonly incorporated are given below.
Sir, your screen is not visible, sir. Can you share it again?
Is it visible now?
No, not yet, sir.
This you see. Next, you see this slide.
No, not able to see.
Mobile operating system.
No.
It's visible.
No, it's here.
I think
Um,
it will.
but for me, the slides are visible.
It is visible. It is also using another device. It is visible clearly. But this the previous slide is there are some that is not that is the text are in small font. So this may not be visible. If you zoom it, you may see it clearly. But the other sides will visible clearly. You see, this is the classification of network. It is visible clearly, I think. Mm, so mobile ad hoc network, you see, man nets. This is a self-confusing and self-organizing wireless network of mobile devices. Sometimes it is termed as man nets. It is mobile ad hoc networks. And the ad hoc network also divided into vehicular ad hoc network. This is, as the name suggests, this is network formed by the communication between moving vehicles and other roadside devices. So you could get communication from only roadside uh, devices. That is why known as the vehicular ad hoc. Wireless mesh network. The device connected to this network forms a wireless mesh depending upon the mobility patterns, nature of devices and inter-device distances, and smartphone ad hoc networks. These are peer-to-peer network created by smartphone within range of each other without requesting any cellular carrier network. And wireless sensor network. Sensor are portable device that are capture specific information from environment like temperature. These are the suppose your any environment uh, information. Suppose the temperature humidity, traffic, volume. So these are the ad hoc network, type of ad hoc network. Mobile operating system. So as you know, the operating system, the role of operating system in a device, in your computer, in your laptop, in your mobile phone, there must be a operating system. Without operating system, you know, you cannot use or your device does not work at all. So there are different there are various important function of operating systems like your process management, your memory management, your security, and the other important roles of operating systems. That is when uh, you boot your system first time, the operating system is the first program which is loaded to the main memory, so that uh, the other work can be done easily, because then the other work is handled by the operating system once the operating system loaded in the main memory. So operating system plays a vital role when you using a devices. Basically, it may be a mobile devices, or maybe a wire network. The operating system must be there. But to in a mobile devices, the operating system where used it is known as the mobile operating systems. Basically, these operating systems are used in mobile devices, your cell phones. The mobile system, the operating system who is used in your cell phone, because your cell phone is a mobile device. You there is no direct connection, the wire connection, your mobile phone with other devices. So it is a mobile devices. So the operating system we are using in your mobile phone or cell phone is known as mobile operating systems. It may be your Android, basically Android you are using nowadays. So it is a mobile operating systems. Many mobile operating system are used for these purposes. You see here the operating system found on smartphone including Symbian OS, iPhone OS, RIMS, BlackBerry, Windows Mobile, Palm Web, Android, and these are the name of Android Web OS and memoir of device from Linux. This iPhone OS originated from BSD and mm, Next TSP, and which are related to Unix operating system. So they are the some name of the mobile operating system. The Android operating system is the most popular operating system as we discussed. So the Android is most popular operating system used in mobile device nowadays. It is a mobile operating system based on the Linux kernel and open source software. The Android operating system was developed by Google. The first Android device was launched in 2008, and the operating systems within it is the Android operating system. It is developed by the company Google. You heard about Bada, the Samsung Electronics. It used in Samsung Electronics. Bada is a Samsung mobile operating system that was launched in 2010. The Samsung Wedge was the first mobile to use the Bada operating system. The Bada operating system offers many mobile features such as 3D graphics, application installation, and multi-point touch. Uh, so BlackBerry operating system, it is also an operating system, is mobile operating system developed by Research in Motion. This operation system was basically designed specifically for BlackBerry handheld devices. That is, any BlackBerry handheld device use BlackBerry operating systems. This operating system is beneficial for corporate users because it provides synchronization with Microsoft Exchange, Novell Group-wise email, Lotus, Domino, and other business software when used with BlackBerry Enterprise Server. Besides that, iPhone OS, you already iOS, we are familiar with the iOS also. like your Android. The iOS was developed by the Apple for the use of its device. The iOS operating system is the most popular operating system today. It is very secure operation. That is why it is used in iPhone. Because the operating system iOS is very secure operating system. Mm, the iOS operating system is not available for any other mobiles. That is, if you are a Apple mobile phone or iPhone, that is the iOS you may use iOS. It is not suitable for other mobile. It is not available. You cannot use this operating system in other mobile. Symbian OS. This system is a mobile operating system and provide high level of integration with communication. The Symbian operating system is based on the Java language, that is, it is written in Java. It combines the middleware of wireless communication and personal information management (PIM) functionality. The Symbian operating system was developed by Symbian Limited at 1998 for the use of mobile phones. Nokia, which was not available in nowadays, was the first company to release Symbian OS on its mobile phone at its. So we are discussing the Symbian OS. The Symbian operating system was developed by Symbian Limited in 1998 for the use of mobile phones. And Nokia was the first company to release Symbian OS on its mobile phone at that time. Nowadays, Nokia, you know that the Nokia at that time popularly used, but nowadays Nokia is not used for these operating systems. They is not upgraded with the other operating systems. So Nokia is the first company to release the Symbian operation, and at that time, the Nokia mobile phones use these operating systems. Windows Mobile Operating System. The Windows Mobile OS is a mobile operating system that was developed by Microsoft. It was designed for the pocket PC and smart mobiles. Harmony OS. The Harmony operating system is the latest mobile operating system that was developed by Huawei. This is a company Huawei which developed the Harmony OS for the use of its devices. So Huawei devices uses this operating system. It is designed preliminarily for IoT devices, Internet of Things. Palm operating system. This Palm OS system is a mobile operating system that was developed by Palm Limited for the use in the personal digital assistant (PAD). It was introduced in 1996. Palm OS is known as the Garnet OS also. The Web OS is a mobile operating system that was developed by Palm. It based upon the Linux kernel. The HP uses this operating system. All the HP devices use this Palm operating system in its mobile and touchpads. The mobile client. A mobile client is a technology designed to extend the features of a company's mobile telephone system. The technology makes it easier for employees to separate personal and business communication while using one smartphone, manage business call while out of the office, transition smoothly from using a company desktop computer to a mobile devices. Suppose you are not in your company, you are outside of the company, so there should be a communication between your company desktop computer to a mobile device. A mobile client is designed to make it easier to integrate portable devices into a company's communication workflows. it has the following benefit. Using a mobile client, your employees can perform detailed customization on how incoming calls or work through the mobile device. These include but are not limited to selective silent modes, ringtones, filtering, and switching easily between private and business phone profiles. More way to communicate. A mobile client makes it easier to bridge the device between desktop and mobile communication. For example, a mobile client allows users to take voice message from their computer or receive mobile calls as though they were inside the corporate network. So any voice come from for their computer, it can receive mobile calls in the mobile phone. So you may get a short question at the short notes. A smart sensor. So as the name suggests, smart sensor. This sensor used in within some wireless devices, smart devices, and it senses the a smart sensor is the device that takes input from the physical environment and uses built-in computer resources to perform predefined function upon detection of specific input and then process data before passing it on. Uh, Suppose there is a sound sensor, you know that if the sound is more in the outsides, so it senses it and perform specific tasks. Suppose a temperature. Suppose when the temperature sensor, this sensor used in many devices, when a devices is working, during the working process, the temperature of the devices increases, and there is a sensor known as temperature sensor senses it. If it is reached at a fixed point, uh, it sense that and instruct the machine to stop. So the machine is stopped from sometimes, uh, so that there are no specific harm to the machine. So smart sensor enables more accurate and automated collection of environment data with less erroneous noise amongst the accurately recorded information. So it senses the many parameter outside of the environment. These devices are used to monitoring and control mechanism in a wide variety of environments, including smart grids, battlefield reconnaissance, explorations, and many science applications. So it senses that it informs the for the particular agents, and then the necessary action will be take place. This smart sensor is also a crucial and integral element in the Internet of Things (IoT). Your robotical, suppose you remember your robotical engineering, your robots has many sensors. That is when a robot is moving, that is if any obstacle comes in front of it, so it senses it, there is obstacles. And you may heard about the car is moving in a busy road without a driver. So it must have a sensor to sense that there's anything is in front of the car, in the way of the car. It may change the direction or it may stops. One implementation of smart sensor is a component of wireless sensor and actuator network (WSN), whose nodes can communicate the thousands each of the which connected with one or more other sensor or and sensor hubs as well as individual actuator. So we will discuss about the actuators. You see, IoT sensor in action. You see, the IoT sensor first has sensor, thermal, sound, and location. Thermal sensors maybe that is maybe sound. Sound sensor if there is particular sound and sound increases a particular range, a particular fixed point, so it senses that. Microprocessor, communication capability, Bluetooth or any infrared or any type of communications. Could also include transducers, transceivers, power source, and more. And it senses that IoT gateway there and access point or hub. So what senses it immediately informs, and particular action will be take place. How does a smart sensor work? Uh, a smart sensor has three components. It has three major components. Each component perform different tasks. A smart sensor has three components: a sensor that captures data, a microprocessor that captures on the output of the sensor via programming and communication capability. So first is a sensor that captures data. It captures data, and a microprocessor that compute the output of the sensor via programming and communication capability. As we see in the previous slides, there is a microprocessor used for that purposes. A smart sensor might also include several other components besides the primary sensor. The component includes transducer, amplifier, excitation control, analog filter, and compensations. A smart sensor also incorporates software-defined elements that provide functions such as data conversion, digital processing, and communication to external devices. It has also contains some integrated communication capability that enable them to be connected to a private network or to internet. This enables communication to external devices. These are the types of smart sensor. Label sensor. The label sensor is used to measure the volume of the space taken of a container. Basically, it is used your tank in your water tank, in your roof, and a vehicle's fuel, fuel gauge might be connected to a label sensor that monitor the level of fuel in the tank. If a fuel tank or your water tank is empty or filled, it is immediately inform the particular agent so that the next action will be take place. Suppose your fuel engine, uh, fuel gauge, so connected to a level sensor. If if suppose your oil is less, it's going to be empty. It sends that, and immediately there should be a signal that comes to the rider so that he know that there should be a shortage of oil, so he may go for fill it. Similarly, water. The water tank also may contain the level sensors. If the water tanks filled, filled already, automatically it senses that and send a signal so that the water motor will be stopped, automatically stop. You need not to go physically to stop the motor. So nowadays the label sensors are used for this purpose. Temperature sensor. A temperature sensor is a sensor that can monitor a component's temperature, so a corrective action can be take place if necessary. In an industrial setting, for example, a temperature sensor can be used to make sure machinery is not overheating. As we already discussed, suppose when a machine is working, when it is running, its temperature gradually grows. and if it reaches a particular temperature, suppose 500 degrees Celsius, 1000 degrees Celsius, or 100 degrees Celsius, whatever maybe, if it reaches, the temperature sensor sends a signal that is the machine is overheating and it is the high time to stop it, and necessary action will be take place, maybe automatically or be manually, so that the machine will be stopped and the temperature will be decreases. So it is uh, uh, used for overheating. That is, the machine should not be overheating if the temperature sensor senses that. Pressure sensor. Pressure sensor is often used in monitor to presence in gases or fluids in a pipeline. Suppose a pipeline, the amount of pressure of a fluid or gas within it can be sensed. A sudden drop in pressure might indicate that there is a leak or flow control issue. Suppose if water come in a water pipe and one day you notice that is the water comes in very low pressure slowly, so there might be a leak in a pipe. So if a sudden drop in pressure might indicate there is a leak or a flow control issue within the pipe. There should be a jam or a leak, so that the pressure will be decreases. So the pressure, so that the necessary action will be taken place. So pressure sensor senses it and send a signal that there will be low pressure. So there will be either a leak or any flow control issue. So for that, the particular action will be take place. Infrared sensor. Some infrared sensor, such as those used in thermal imaging camera or non-contact infrared thermometer, are used in temperature monitoring. Other infrared sensor are optical sensor used in the frequency that enable them to see light in the. So nowadays you see at the thermometer, the digital thermometer we are uh, using for to read the temperature. Other infrared sensor are optical sensor on frequency that enable them to see lights in infrared spectrum. These type of sensor are used in medical equipment such as pulse oximeter devices. The pulse oximeter devices, a devices which is attached to your finger to read the uh, pulse rate, and the electronic device designed to be operated by remote control. The remote controller also some remote controller use infrared sensor. Proximity sensor. A proximity sensor is used to detect the location of a person or object with relation to the sensor. In retail environments, proximity sensor can track customers' movement throughout the store. So, if a particular person, the movement of a particular person or movement of a particular object within the particular range, a person moving in a store is sensitive that this is the location, this is the movement of a object or movement of a person. So this is the proximity sensor. So as we discuss, the sensor plays a vital role in robotic engineering. A robot contains many sensors while it performing, while it working. While it is working, suppose while it is working, any obstacles comes in front it, it senses that there's obstacles, there's a wall, there's a table, there's a chair. So it immediately knows that. It also senses it is power. Suppose you know that is a robot works by taking some power, maybe electricity, maybe other power, maybe other energy. So it is also know that uh, the senses that it's a power, it needs some power, or it is need to charge. So sensors and actuators. Sensors and actuator allow robots, as you know that both the two things we'll discuss about the sense actuators. Sensor and actuator allow robot to achieve certain tasks. So basically these are associated with the robotic engineering, with the robots. Examples of what robot may need to determine include how far away and where it is an object, like another object or another obstacles. It also determine that. At what speed is the robot moving? In which speed robot should be moved? If the robot is in the hill, at what angle is it? If the robot is rotating, by how much has it rotated? How can you change the direction? Where is the robot or what direction it is going? How far it has it traveled? How much power, as already discussed, power consumed? How much power has it consumed? What information is being communicated to the robot? So this is the sensors and actuators. The robot may require internal and external sensor. The internal sensor and external sensor. As the name suggests, external sensor are used to measure the object, for instance, how far away for an object and where is the object. That means these facts are outside of the robot. Is there any obstacle in front of the robot while working? So this is an external sensor. But when we sense within it, inside it, you see, internal sensor are used to measure the robot itself, for instance, how fast it is going, the angle of the robot, where it is gripper, and how much power it is consuming. So these are the internal things, and this is censored by some sensors we know as the internal sensors. So more about actuators. So please write your name and registration number in the board.